Hello everyone, welcome back to Conarchy YouTube channel. In our previous videos, we've been able to define our various loads. That's our dead load, our live load, and our seismic load. And I believe we all get how to do that now. So our next thing that we have to do now is to define our wind load and assign it onto our structure. So if you've not liked or subscribed to the video, try to do so before we continue. Like today's video, subscribe to the channel, and also turn on your post notification just in case we drop a new video. You can just get that and just watch it as soon as possible. So let's get started. So as I said earlier, we are going to define our wind load and assign it onto our structure. And we know that before we define a load, we have to define them because they are not really, when it comes to these lateral loads, they are not really defined in the app. So we have to define them ourselves. So define load pattern and wind. So we are going to represent that by wind. And we know that with these lateral loads, they occur in the X and Y. So this is for the wind X. And the type of load is the wind load. The self-weight multiplier is 0. And for this one, the code we are going to use to define our load. So for when it comes to the wind load, we have our BS code here, BS 6399. So there is it. Then we just add our new load. And we're also going to do that for the Y. And we just add new load. So now we have our X and Y. So all we have to do now is modify it per our design. So we are going to modify this wind X. So when we open this modification tab, we are going to find this over here. You can see that there are various options here. I'm going to explain each and every one starting from here. So first of all, we have exposure and pressure coefficients. This is to tell us that there are two different ways of defining or assigning your wind load onto the structure. We have exposure from extent of diaphragm and exposure from shell objects. I'm going to explain both of them so you are going to understand how they work and how you are going to go about with it. So first of all, I'm going to stick with the exposure from shell objects. I'm going to explain this one. So but before that, we have to define all of these. We have the effective speed, that's the wind speed in your locality. So based on your country wind diagram, you have to research that and see your wind speed in that locality. So for a place like Accra, checking my wind diagram from the country. So for this one, you have to do your research to know that. So for a place like Accra, this place is very windy, and so I can stick with a wind speed of like 35 meters per second. I'm not going to change the size effect factor, dynamic argument factor. I'm going to leave everything as such. And next, the exposure height, the top story, that's story 5, and the bottom story. So with this, is going to pick from your model the topmost story and the bottom story. And once you are done, you can just click on OK. So you can also do the same for the Y, as in modify lateral loads, exposure from shore, then 35. Then you can click on OK. So we are done defining the load. But as we specified earlier, is exposure from shell. With this type of assigning the load of the wind load onto the structure, we have to create some form of cladding. The cladding is like a wall-like structure around the building. It does not really have any self-weight. It has no mass. It's not a structural element. It's just some wall-like structure we create around the building to facilitate or simulate the distribution of the lateral loads onto our vertical structures or anything in the structure that is helping the building to resist or just combat this lateral loads like our column or our shear wall. So all we have to do now is to draw our cladding. So draw, and we have auto draw cladding. So with this auto draw cladding, we have various ways of drawing the cladding. We have the use floors, use beams, use columns. So for us, we want our cladding in this whole place, so we can use floors at every floor. And we also have use selected objects only. You can select the objects you want your cladding to be around and just assign it. But we want our use floors because we want it in every floor. So we're going to click on OK. So that's our cladding over here. You can see that we have our cladding. This cladding, they have no mass. Let me click on it for you to see. So I'm going to right click, and you're going to see the this is a beam rather. So here, yes, so this is the cladding. You see that, and you see the section property. You can see that it's none. That means it has no section property. It's just there to facilitate the distribution of the lateral loads onto the structure. So once I'm done assigning this lateral load, this cladding onto my structure, all I have to do now is to assign my wind coefficients. So I'm going to explain how or take you through how you're going to do that. So first of all, you have to, let's say we are assigning, as I said earlier, we have our wind X and our wind Y. So let's look at our global axis over here. We have our X direction in here and also our Y direction here. So we want to assign our coefficient. So let me place it in the elevation A, this A. Yeah, I think so. Yeah, A. So elevation A and apply. So I'm going to assign my my coefficients onto this cladding. So before I do that, I have to select this shell. So let me just click on all stories, select this shell. Let me see, I think the staircase too. Yeah, I can do that. So that's on A, B, C. So elevation C. Okay, I think that's the staircase here. You can select that. Okay, so now once I'm done selecting these shells, you can see that I have 20 shells selected over here. So this is going to tell me that 20 shells have been selected. Once you count, you can see that yes, there are 20. So 1, 2, 3, 4, 5, and 1, 2, 3, 4. So 4 times 7, that's 20 shells there. So once you are done selecting these, you can now come to assign and shell loads, and we have this over here. So in case you've done your own calculation to know your wind load, your loads, uniform loads, as in the UDL of the wind that you're going to assign onto the structure, you can just come to the uniform load and maybe assign, like maybe after your calculation you had like 10 kilonewton per meter square, 5 kilonewton per meter square. You can just assign that. But since we've not done that calculation yet, you are going to stick with the wind pressure coefficient. Okay, so now when it comes to the wind pressure coefficient, you have to understand what these coefficients mean. So I'm going to take you through that too. So with a wind pressure coefficient, they are dimensionless factor used in structural and wind engineering to estimate the distribution of wind pressure on a structure's surface. So these coefficients relate the actual wind pressure acting on a structure on the surface to the dynamic pressure of the wind. So with this, there are 5 values that contain the static lateral loads of the wind, and they are just going to assign them onto the structure. So with the wind pattern, we are going to assign our wind X and the coefficients. So we have windward side. So we are going to assign our first pressure coefficient, the windward side. So when we talk about the windward side of a structure is where the wind directly impacts the structure. So that's, let's say that here we are talking about the wind X in this direction. So this side that I've selected is going to be my windward direction, and the leeward side, this is the opposite face of the structure where the wind creates a suction effect. So this is the opposite side. The opposite side is going to be the back here. That's going to be my leeward direction, but this is my windward direction. I'm going to assign that. So with the windward direction, the wind pressure coefficient is positive, representing a pressure force. So it is mostly 0.8 for walls at 0 degrees incidence. So with that, I'm going to input 0.8 for the windward direction, and I'm going to apply. Once I do that, you can see that these arrows, that means 0. In this windward direction, they are applied this pressure coefficient 0.8. So you can refer to the BS code to understand what this pressure coefficient really means. I'm going to add that to the link in the description. I'm going to put that link in the description below so that you can also read more about the wind pressure coefficients. So once I'm done, I can just go back to this place and select the opposite side of the building and assign my leeward wind pressure coefficient. So that one is also the wind X. but it's in the leeward. So with the leeward, the coefficient is mostly negative, representing a suction force. So this part of the building will be in suction, and the value is negative 0.5. So this depends on the building geometry and the wind angle. So 0.5, I'm not going to put that negative over there because the software already understands that the leeward side is going to be in suction, that means the opposite direction. So I'm going to do that as 0.5. That's the wind pressure coefficient for the leeward side. And once I'm done, I can just also click on apply. So looking at the arrow over here, you see the arrow is in the opposite direction compared to the first one I did. So this is to show that 0.5 is in the leeward direction. So once you are done, you can also go and also do for the y direction. So just looking at that, so y direction, it's over here. Yeah, my y direction. So you can also select these shells in the y direction in this place, and also this place too. So it's at all storage. So once I select this first shell, everything below is going to be selected, and I'm just going to change this wind load pattern name to WY, representing my wind force in the y direction. And since this is where the y direction is going, this is going to be my windward surface. That's going to, I'm going to input the 0.8 over there. So 0.8 for the windward direction, and I'm going to apply. You can see that also over here. And I'm going to move in the leeward direction. That's the opposite side of the building. So I'm going to select the cladding over there also, and I'm going to input 0.5 for the leeward side. So then apply. So that's how to do with the leeward using the exposure from shell objects. So applying your windward and the leeward side. But I'm not going to run this model yet. I want to take you through the second method. Once I'm done, I'm going to run the model and show you how to analyze your wind structure, how it's going to displace the building and everything.